Start the recording. All right, and I'm gonna switch my screen for just a second. All right, and we're gonna take a look at the half. We're gonna kind of continue with the half number identities, and we're just gonna start. I'm gonna give you about 5 minutes to work this problem, and then I'm gonna return with the solution, and then we'll kind of look at the rest of the examples. All right, we're gonna go ahead and get started, and we're asked to find the. Okay, we're asked to find the cosine of 13 pi over 12 using the half angle formulas. So if we refer to the formula sheet, give me 1 second, I'm going to bring that up. All right, under our half number identities, we see here is the half angle for cosine, and it says that the cosine of a over 2 is equal to plus or minus the square root of 1 plus cosine a divided by 2, right? So that's the formula that we're going to use. All right, so if I were to change, let's see, 13 power over 12 to an angle measure, excuse me, to a degree measure, I have 13 times 180, and that's a 12, divided by 12. Right, and that gives me 195 degrees. All right, and I'm asked to use a half angle formula. Now, if I look in the unit circle, I see that there is not a 195-degree angle, right? So here's the trick I'm going to play on this. Now, normally in the example that I showed before we left, we were able to take an angle that was in the unit circle and kind of cut that angle in half, all right, because these angles in the unit circle, they run from 360 degrees. What I'm going to do in this case is I'm going to take the 195-degree angle, which we have, right, and I'm actually going to double it. I'm going to multiply it times 2, and I get 390 degrees. All right, so I'm going to write this as the cosine of 390 degrees divided by 2. Right. So you also notice that 390 degrees, it's, if I go back to unit circle, it's not actually in the unit circle. However, I could find its coterminal sister that would put it in the unit circle. All right, so what I mean by that is if I have 390 degrees, I'm going to subtract 360. And I see that 390 degrees and 30 degrees are coterminal, right? They start at the same spot and they end at the same spot. So I don't actually have 390 degrees in my unit circle, but I do have 30 degrees, right? So the cosine of 30 degrees would in fact be the same as the cosine of 390 degrees. All right, so above the cosine of 390 divided by 2, I'm going to write the formula for the half angle for cosine. So the cosine of a over 2, right? So we've established the fact that a is 390 degrees. That's equal to plus or minus times the square root of 1 plus cosine a divided by 2. All right, so here the first thing we must do is establish the sine. Okay. So now we're actually trying to find the sine of, we're actually trying to find the sine of the cosine of 190 degrees. Right, so if I just draw out a rough sketch, and we have 0 degrees here, 90 here, 180 here, 270, and then one complete rotation is 360. Remember, from our reference angle, all students take courses, right? These gives us the sines of the 6 trig functions in each 4 of the quadrants. So notice that a 195-degree angle would lie in the 3rd quadrant. Okay. Right, so if our angle is in the 3rd quadrant, the only positive values are the tangent and the cotangent. Everything else is negative. So the first thing I'm going to do is establish my sine. So the cosine of 195 degrees, it should be negative. Right? So the first thing you want to do is establish your sine based upon the angle that you're actually trying to find. Right? So we've established the sine. So that should equal to a negative times 1 plus the cosine of A, right? So keep in mind that A in this case is 390. We've already established the fact that 390 degrees and 30 degrees are coterminal angles. So I'm going to put an extra step in here. So I'm actually going to use the cosine of 30 degrees divided by 2. So that's equal to the negative times the square root of 1 plus, and if I look within my unit circle, I see that the cosine of 30 degrees is square root of 3 over 2. Divided by 2. Now I was kind of looking at some of the problems and the way that I worked the problem out in the last class was sort of different than what I actually seen on the viewing example. So I'll kind of show 2 ways on how to work this. This is what I did in the last class. I got rid of the fraction in the numerator, right? So I multiplied the numerator and the denominator by 2. 2 over 2, right? 2 over 2 is a special form of 1. The next thing I did was I distributed 2 in the top and in the bottom. So 1 times 2 is 2. The square root of 3 divided by 2 times 2 gives me the square root of 3. In the denominator, 2 times 2 is 4. Right. Then I believe we use the quotient rule for radicals. So we have negative square root of 2 plus the square root of 3 over 2. Right. Now looking at the homework problems, right, they worked it out sort of differently. So I'm actually going to take it from this step here. So this was negative times the square root of 1 plus the square root of 3 over 2 over 2. Okay, so they kind of left everything in the square root. Okay, so just to show the solution that they're getting. From this point, I believe they used the divide by a monomial. Formula, and it says that a plus b over c, that's equal to a over b, a over c plus b over c. Right, so that divide by monomial was applied here. So I have 1/2 plus the square root of 3 divided by 2 all over. And I'm going to write this as 2 over 1. Right? So this is all within the square root. Just make this look a little bit better. Right? So this is a negative times the square root of 1/2. And then there was another formula that we talked about, A over B all over C over D. That's equal to A times D over B times C. So you can multiply the very top and the very bottom. So the square root of 3 times 1 is the square root of 3. And then 2 times 2 is 4. All right, so you've sort of seen a solution that looks something like that as far as the problems are concerned, but they will accept both of these solutions. All right, so any questions about this problem? All right, so once you take your angle measure and double it, right? We took 195 and we doubled it. And that angle may or may not be in a unit circle, but you should be able to either subtract or add 360. That will give you some angle within the unit circle. Oh, I closed it down. All right, so I'm going to go back into XYZ for a second. All right, and what we're going to do from this point is I'm going to bring back up the formula sheet. And we're going to take a look at the last the last box of formulas. They are the product to sum identities and the sum to product identities. Now, if we take a look at the product to sum identities, notice that on the left-hand side of our formulas, we have products. So this first product is cosine A times cosine B, and that's equal to 1/2 the cosine of A plus B plus the cosine of A minus B. Right? Next, we have sine A times sine B. We have its formula. Then we have a mix of sine and cosine. So in the next form, we have sine A times cosine B, and we have cosine A times the sine of B. Notice that from the last example, or from the last section, we can actually take the formulas, we can use them in reverse, and we can modify them. So when we're using the product, the sum, and the sum to product formulas, we're simply taking a formula, right, that fits the pattern of our problem, and we may or may not have to manipulate the formula in order to get the solution. Now, when you're working with the product, the sum, and the sum to product rules, you have to be mindful of the negative number identities. All right, so just to review that slightly. Okay, I'm going to go back to our class for just a second. I'm going to go into lecture notes, and I believe this was in, 9.3. I'm sorry, I believe it was 9.2. Okay, I may just have to write them out. Okay, here they are. They're at 9.1. All right, these negative number identities. So it says that the sine of negative theta, right, that's equal to negative times the sine of a positive theta, right? So keep in mind that we can write a negative angle as a positive angle using the negative number identities. The cosine of negative theta is equal to the cosine of theta. The tangent of negative theta is equal to negative times the tangent of theta. Now in our sum and sum the product and product the sum formulas, notice that we're only dealing with the sines and the cosines. All right, so let's take a look at an example. I think I'm just going to bring up another page here. All right, and I'm going to pull a problem from this section. Let's see, this is... All right, let's take a look at number 1. This is 3.4 problem number 1. We have 14. Well, the directions tell us to rewrite the product as a sum or difference. And we have 14 times the cosine of 11y times the cosine of 10y. All right, so that's 14 times the cosine of 11y times the cosine of 10y. So we're asked to rewrite this product as a sum or a difference, right? So we're given a product, and we're looking for the product formula that has some type of cosine times another cosine. Right, so I'm going to bring back up the formula sheet. And if I look at my product, the sum formulas, notice that we have this first formula, cosine A. I'm actually going to write that down. Cosine A times cosine B. That's equal to 1/2 times cosine A plus B plus cosine A minus B. Right, so notice we have the cosine times another cosine, so this is the formula that we're going to choose. All right, so above that, I guess below that, because we have to manipulate the formula. All right, so we have cosine of A times the cosine of B. That's equal to 1/2 cosine A plus B plus cosine A minus B. All right. Okay, so notice I have the same setup or sort of the same setup. But notice in my formula, right, I could substitute, 11y for A, and I can substitute 10y for B. But in the formula, the coefficient for that cosine A, cosine B term is a 1. We need for the coefficient to be a 14, right? So then it would line up exactly. So with that being said, in order to change the coefficient from a 1 to a 14, that means we have to multiply both sides by 14. Right? Whatever you do to one side, you must do exactly the same thing to the other side. Right? So if we multiply both sides by 14, the new formula now is 14 times cosine A times cosine B. That's equal to 7, right? Because 14 times 1/2 is 7. Times cosine of A plus B plus the cosine of A minus B. right? So notice we've taken the cosine product formula, we multiply both sides by 7, right? So now that we have the newfound formula, I'm simply going to rewrite our problem under the newfound formula. So that's 14 cosine 14 cosine 11y cosine 10y is equal to 7 times the cosine of a plus b, so that's 11y plus 10y plus the cosine of a minus b, so that's 11y minus 10y. Right? And then we're going to simplify. So this is 7 times, and make sure to keep a parenthesis or a set of brackets, right? Because if not, you would have to distribute that 7, okay, which we're not doing. We're just going to leave it in this multiplied form. So 11y plus 10y is 21y plus 11y minus 10y is y, so that's plus cosine y, and we have the solution. All right, so notice that you can manipulate the formulas. Whatever you do to one side, you have to do the same thing to the other side. All right, and then notice for my final result, you must include a set of brackets. And I'm also noticing that you must include a set of parentheses for the arguments of your trig functions. All right, so the next thing we're going to do is we're going to look at sum the difference. So in this example, this is similar to number 7. I'm going to just write this out as 3.4.7, and we're asked to rewrite the sum or difference. Okay. Now, believe it or not, the product, the sum, and the sum, the product are some of the easiest formulas to use. They just sort of look scary, right? But once you find the right pattern, you may have to manipulate, you may not have to manipulate, but once you find the right pattern, it's just a matter of substituting and simplifying. So here we have cosine of 4y plus the cosine of 2y. And we want to rewrite the sum or difference as a product. So we're going to look at the sum and difference formulas, and we're going to find the one that fits a cosine plus another type of cosine. All right, so looking at the formulas, we see that the third formula is a cosine plus another cosine type formula. So I'm going to write that down. Cosine A plus cosine B is equal to 2 cosine A plus B over 2 times cosine A minus B over 2. All right, so I'm actually going to write that above the formula. So we have no need to manipulate in this particular formula. So we have the cosine of A plus the cosine of B, right? So we're going to substitute A for 4y. We're going to substitute B for 2y. That's equal to 2 times the cosine of A plus B over 2 times the cosine of A minus B over 2. All right, so substituting into the formula, we have 2 times the cosine of 4y plus 2y over 2 times the cosine of 4y minus 2y over 2. Right, we're going to simplify that down some, and we have 2 cosine 6y over 2 times the cosine of 2y over 2 for a final result of 2 times the cosine of 3y times the cosine of y. Right, so pretty straightforward. Now, in some instances, you may have to use the negative number identities, right? Because you want to make sure that all of these angle measures are positive. All right, so let's take a look at one that requires that. All right, so this is similar to problem number 8. So this is 3.4.8. And we're asked to rewrite the sum as a difference, or the sum or difference as a product. So here we have the cosine of 4z plus the cosine of 10z. Right, so we're going to use the same formula that we did in the previous example, right? Cosine 4y plus cosine of 2y. So the formula says that the cosine of A plus the cosine of B, right? So here again, we're going to no need to manipulate the formula. We're simply going to substitute A for 4z and B for 10z. Right, so that's 2 cosine A plus B over 2 times cosine A minus B over 2 so that's 2 times the cosine of A, which is 4z, plus B, which is 10z over 2, times the cosine of A, which is 4z, minus B, which is 10z over 2. Right, and if we simplify, we have 2 times the cosine of, well, 4z plus 10z is 14z over 2, and 14z divided by 2 is 7z, times the cosine of 4z minus 10z, which is negative 6z, and negative 6z divided by 2 is negative 3z. From our negative number identities, the cosine of negative theta is equal to the cosine of positive theta. So I think they may let you get away with this, but technically you should write this out as the 2 times the cosine of 7z times the cosine of 3z. Okay, I'm just scrolling down through some of the problems. All right, and I think these things are pretty straightforward in this section. I believe there was one or two where you may had to manipulate a formula. I think that was problem number 1. Okay, problem number 2, problem number 3. I believe the first 3 problems you had to manipulate a formula, right? But the rest of the problems were pretty straightforward. Let's see, evaluate the sum of difference. I'm just making sure. Okay, some of these things. Okay, well, let's take a look at this one. This is similar to number 11, 3.4, number 11. And we're asked to evaluate the product using a sum or difference. And it says to leave in terms of sine and cosine. Right. So we have 2 times the sine of 19 degrees times the sine of 18 degrees. Right, so we want to rewrite this product as a sum or a difference. So I'm going to look at the sum or difference products, and I'm going to look for the sine times the sine pattern. All right, so looking at the product sum formulas, I see that the very second formula is a sine A times the sine B. All right, so that formula says sine A times sine B is 1/2 cosine A minus B minus cosine A plus B. All right. So we do have to modify our formula in this instance. So I'm just going to rewrite the formula. So it's sine of A times the sine of B. That's equal to 1/2 times the cosine of A minus B minus I'm just making sure that I have the right formula. Yeah, cosine. So that's cosine A minus B minus cosine A plus B. All right, so in our problem, we could substitute A for 19, we could substitute B for 18, but notice our coefficient is 1. So in order to make the problem match the formula exactly, I'm going to multiply both sides of the formula or this equation by 2. Right. So if I write out the left-hand side, I have 2 sine A sine B, right, which now fits our formula exactly. On the right-hand side, 2 times 1/2 is 1, so I'm left with cosine A minus B minus cosine A plus B. And now I'm going to substitute. Right, I'm going to substitute A for 19 degrees and B for 18 degrees. Right, so that's the cosine of, well, 19 degrees minus 18 degrees is 1 degree, minus the cosine of A plus B, well, 19 plus 18 is 37 degrees. All right, and that should be our solution. All right, so any questions about the sum to product or product to sum formulas? Okay, they just look scary. All right, but they're actually easy to use. Once you find the pattern, it's just a matter of substituting. I would use the negative number identities just to make sure that you write any negative angles as positive angles. Now I want to jump into the very last section. I just want to touch on that lightly. Okay, we'll actually go in a depth a little bit more in the next class. All right, and it's solving trig equations. And when we solve trig equations, you want to keep in mind that the answer to any trig equation is an angle measure. Just bring this back over. So the answer to any trig equation is an angle measure. What we do in solving trig equations, we try to rewrite everything as a single trig function. So that requires you to use the formulas previous in this section to simplify. Once you simplify your trig function, you'll then solve the trig function. And we're going to look at two methods to solve, or actually we'll look at three. There is something called a linear method to solve a trig equation. There's something called a quadratic method to solve a trig equation. And we could also use a calculator. All right, but before we begin any of that, I want to show you that you can factor trig functions. And here's what I mean by that. Okay, and I believe my pen is going dead. We're going to take a look at factoring as it relates to algebra. Okay, and then we're going to evolve up to trig functions. And I'm trying to make my pen a little bit thicker. Okay, how are you supposed to do this? All right, so we're just going to look at factoring. So let's say you were asked to factor x. Let's say that you were asked to factor x squared and I thought it was a way I can make this actually darker. X squared plus 5x plus 6, right? And let's say you were asked to factor x squared plus 5x plus 6. So we're going to factor, we're going to make two sets of parentheses. Just keep in mind whatever you put as your first terms, right? You must be able to multiply and get the first term in your trinomial. Remember that factoring and the FOIL method are like reverse processes, right? So if I were to go back and FOIL this together, x times x is x squared. The next thing you want to do is determine your sines. So when you determine sines, see x squared plus x plus c, and I have no idea what's going on with my pen. X squared minus x plus c, x squared plus x minus c, and x squared minus x minus c. All right, so basically these would be your setups, and I have all the different possible combinations. And this is how you determine your sines. All right, so like for each one of these things, you're going to have x, right? Because when you multiply the first terms, you must get the first term in your polynomial. When you determine sines, okay, this is how this works. If your last term is positive, then both of your numbers are going to have the same sign as your middle term, right? So since this last term is positive and my middle number is positive, both of the signs are going to be positive. If I look at the second scenario, my last term is positive, so that means that both of the numbers are going to have the same sign as the middle sign. Therefore, both of these numbers are negative. Right, so in a nutshell, if your last term is positive, you're going to have both of the numbers you're using are going to have the same sign as the middle term. However, if your last term is negative, right, like in these last two setups, it does not matter what the sign of your middle term is. One of the numbers is always positive and one of the numbers is always negative, right? And this is how you should determine sines. So now just by knowing that, looking back at our example, the last term is positive, the middle term is positive, so we know that both of our numbers are positive. Now we're going to use something called a product sum, right? We need two numbers, both are positive, whose product is equal to 6, right? So the product always equals to the last term, and the sum is equal to the middle term, which is 5. So now if we look at the factors of 6, okay, you can get 6 by 1 times 6, but if you add 1 plus 6, you get 7, which is not a 5, so 1 and 6 are not the factors. We can use 2 times 3, right? 2 times 3 is 6, 2 plus 3 is 5, so the numbers we are to use are 2 and 3, right? I can go back and actually check my factorization by using the FOIL method. So that means if I take x plus 2 times x plus 3, and if I were to multiply those together, I should get x squared plus 5x plus 6. All right, so I'm going to FOIL that out. So I multiply my first terms, x times x is x squared. I can multiply my outermost terms, 3 times x is 3x. I can multiply my innermost terms, 2 times x is 2x. And I can multiply my last terms, right? A positive times a positive is a positive. 2 times 3 is 6. And if I combine like terms, I have x squared plus 5x plus 6, right? You can do the same thing for trig functions. All right, so here's an example. We're asked to factor and give me 1 second. We're going to factor 2x squared minus x, 2 cosine squared x minus cosine x minus 1. All right. So we're going to factor 2 cosine squared x minus cosine x minus 1. All right, so we're going to factor pretty much the same way that we factor in algebra. So I'm going to count it really well. All right, so I'm going to make 2 sets of parentheses. What I put as my first terms, I must multiply and be able to get 2 cosine squared x. Right, so I'm going to multiply 2 cosine x times another cosine x. Right, because 2 cosine x times cosine x is 2 cosine squared x. Right, I get my first term. Now I have to determine my sines. Okay, and here's where a little bit of trial and error comes in, or trial and check, I should say. Since my last term is negative, I know that one of my numbers should be positive and one of my numbers should be negative. Right? So I have to, this is called a trial and check. So I'm going to make the first term negative and I'm going to make the first term positive and the second term negative. Whatever I put as my last terms, I must be able to get a -1. And I must also be able to get a sum of 1. All right. So for this instance, I'm just going to put in a 1 and a 1. Right. I'm just going to check this out to see if I get, in fact, I get what I need. Right, so if we were to use a FOIL method, 2 cosine x times cosine x, that's 2 cosine squared x. If I take my outermost terms, 2 cosine x times -1 is -2 cosine x. If I multiply my innermost terms, 1 times cosine x is cosine x. And if I multiply my last terms, a positive times a negative is a negative, and 1 times 1 is 1. And now I will combine like terms. Right, so I'm going to bring down my two cosine squared x. -2 cosine x plus cosine x gives me negative cosine x minus 1. Right, so I know that this is the correct factorization. Now we'll see why in a second it's important to be able to factor quadratic equation. To factor trig equations. All right, so we can factor them. There are 2 methods that we're going to use in this course. One is called a linear method. Now keep in mind, this was taken from a different textbook. All right, so the information is a little bit different, but it's pertinent to this course. So this says solve a trigonometric equation by linear methods. Right, and we're going to talk about what a linear method is. And then it says solve a trigonometric equation by a quadratic method, right? So what is a linear method and what is a quadratic method? All right, and to explain it, I'm sort of going to go back to algebra first before we actually jump into the trig part of things. So here we have a linear equation. So solve the linear equation. Two x minus 1 is equal to 6. Or I'll make this 5 just to keep everything nice. All right, now what makes this a linear equation? Well, what makes this a linear equation is that my variables have no power past the first power. All right. So notice I have the only variable here is x, and x is raised to the first power. So that makes this a linear equation. Okay, on the next instance, we're going to solve a quadratic equation. So let's say we have x squared plus 5x is equal to -6. Right? This is a quadratic equation because the highest power is a square. Right? So that would be a quadratic equation. Now, the way you solve these things are totally different. In order to solve the linear equation, we must isolate the variable. Okay, so what does that mean? That means that we must put the variable on one side, we put everything else on the other side, and then we can solve. So here's the linear method. In order to solve 2x minus 1 is equal to 5, the first thing I'm going to do is add 1 to both sides. So I have 2x is equal to 6. In order to isolate the variable x by itself, the opposite of multiplying x by 2 is to divide by 2. Right, so I'm going to divide both sides by 2. And if I divide both sides by 2, I have x is equal to 3. Right. Now I can check my solution. Right. In order to check, and this is true of trig functions, in order to check your solution, you go back to your original problem. Right. 2x minus 1 is equal to 5. And we're going to substitute the extra 3. If x is the solution, it's the magic number that'll make both sides equal to each other. All right, so wherever I see an x, I want to substitute a 3. All right, 2 times 3 is 6. 6 minus 1 is 5, so 5 is equal to 5. Right. So that is a linear method. The linear method means you must isolate. First off, you must have a linear equation. A linear equation means that the variable or the trig function is raised to the first power. Here is a quadratic method. In order to solve a quadratic equation, you must first put the equation in standard form. Right? So standard form just means that you have to set it equal to 0. So set equal to 0. And then you want to solve. Right? So remember, when you're solving quadratic equations, there were a couple of different methods, right? You could factor and use the zero factor property. Right, and this should always be your first mode of operation. I don't know if my pen is dying or what, but factor and cancel should be your first mode operation. Then you could use the quadratic formula. These are the only two methods that I would use when solving trig equations. All right, now you could use like complete the square and what else that? The square root property, right? Well, I should put that square root property. Okay, these are the three methods that you should use, right? I wouldn't use complete the square. Okay, but the factor and cancel pops up, the square root property pops up, and then in some instances, the quadratic formula pops up. All right, so let's take a look at solving this equation. All right, so first thing we got to notice is that it's quadratic because we have a power of 2. All right, the largest degree or the largest power is 2. So we're going to put it in standard form, which means we're going to set it equal to 0. So I'm going to add 6 to both sides. Right. Now I'm going to factor. Right, so we factored this earlier. So we have x and x. All right, it's still set equal to 0. My two numbers are positive. The two numbers I'm going to use are 2 and 3. The zero factor property, I'm going to write that over here. The zero factor property says if a times b is equal to 0, right? So notice that's a product. That's a times b, right? I have two factors. A is my first factor. B is my second factor. Then you can take each factor and set equal to 0. Right? So if a times b equal to 0, then you can take a equal to 0 and you can set b equal to 0. Right? So that's what I'm going to do here. And in this instance, a is going to be x plus 2 and b is going to be x plus 3. So I have x plus 2 equal to 0, x plus 3 equal to 0. Right, and these things are now linear equations, right? Because the squares disappeared since we factored. And in order to solve, we're going to isolate. So x is equal to -2 or -3. Here again, you can check your solutions. Right? So in order to check, we can only check one solution at a time. Right? So we're going to go back to our original equation. X squared plus 5x is equal to -6. We're going to substitute in -2 for x. Right, so we have -2 squared plus 5 times -2. That should equal to -6. So -2 squared is 4. 5 times a -2 is -10. And we have both sides equal. Right. Now I'm going to bypass -3, but -3 should also check out. Right. Both of these things are solutions. All right, so now we'll take a look at, I guess, one example. All right, and it's this one. It says solve the trig equation. We have solved 2 sine x minus 1 is equal to 0 over the interval from 0 to 2 pi. So we want to solve 2 sine x minus 1 is equal to 0. 2 sine x minus 1 equal to 0. All right. So the first thing you should notice is that this is a linear equation, right? Because I have the sine of x, and that sine is raised to the first power. right? Now, if this were like 2 sine squared x minus 1, that would throw it into the realm of being a quadratic equation. All right. So if you have a square, you treat it as a quadratic. If you don't have any powers, then it's a linear equation. It's a linear trig equation. So in order to solve it, we're going to isolate for the sine of x, right? So in order to isolate the sine of x, right, I'm going to add 1 to both sides, and I'm going to divide by 2. So the sine of x is equal to 1/2. So now there's something in the directions that is very important. It says solve 2 sine x minus 1 is equal to 0 over the interval from 0 to 2 pi. So solve in the interval from 0 to 2 pi, right? So what does that mean? Well, we're going to interpret this as what angle in the interval from 0 to 2 pi has a sine or y value, right? Remember the sine is a y value of 1/2. Okay, so now keep in mind, these are not inverse functions. Okay, inverse functions were something totally different, right? We're looking at all of these things in the interval from 0 to 2 pi. So I'm going to pull out my unit circle, right? So we're going to completely around the unit circle. We're looking for all angles that have a y value of 1/2. So I see that 30 degrees or pi over 6 has a sine value of 1/2. And also 5 pi over 6 has a sine value of positive 1/2. So my two angle measures here are pi over 6 and 5 pi over 6. Right, so the angle x that we want are pi over 6 and 5 pi over 6. All right, so we have pi over 6 and 5 pi over 6. And I think we'll stop here when we pick up again. I just got out of the stat class late. They just had some questions in there. But when we meet again, we'll take a look at solving this trig by using a quadratic method, right? And then we'll kind of take a look at some problems in the homework that require the use of some of the different methods for the quadratic. Okay, there's some you have to use factor and cancel. There are some problems where you have to use the square root property. I didn't really see any that use the quadratic formula, but I'm going to go and kind of thoroughly check them before we meet again next Monday. All right, so at this time, I'm going to stop the recording.